in order to do exploratory data analysis, which to use a less fancier term in terms of analysis, exploratory data analysis is essentially just getting a breath or getting a feeling of exactly what is in your data. There are several tools within pandas that you can utilize, whether or not you're utilizing a data frame or a series. So we can view the first two columns. We can view the last two columns. No, these are not columns, these are rows. Sorry. We can see the first two rows. We can see the last two rows. We can want to see which student had the maximum marks based on our data frame above here, as well as we are interested in seeing a numerical statistical breakdown of exactly what our data frame holds, as well as checking the data types within each particular column in a data frame or generally within our single series structure. So in order to see the first few items, let me put it that way, we use the function called df.head. Now, df.head shows you, df.head, when you write it just naturally like that, closing with the rounded brackets, it usually shows you the first 5 values within your data frame. But in this case, because we only have 3, it's showing us the entire data frame. However, you can specify how many records from the beginning you want to see using .head by specifying a given value. So when I call df.head in brackets 2, I specify that I only want the first 2 items within my data frame, as well as checking the last 3 items within our data frame. In order to do that, you call df.tail. And what this does, essentially, it calls in the last specified items. So by default, just like head, when you call df.tail, it only shows you the last 5 items. But yet again, we are a bit constrained here because of the size of our data set. So we can check, let's say, the last 1 item, of which was Miss Elizabeth. In order to check the maximum marks, we simply call in the particular column of which you're looking for. So df marks in square brackets, and then we call .marks. Very direct, very simple, very similar to what we saw in NumPy. Another thing that probably I should mention now is there's also another way of which you can call columns directly, though its functionality is relatively limited, especially when your script gets very complex or very complicated on the long run. That's why we encourage people to focus on calling their columns in this particular format. However, this does work. Now, the reason why this works is because whenever you use dot in Python, it means that you're referring to something within a particular object. So if I could take your attention to take a look at this address. Let me copy it and then I put it somewhere bigger so that it's easier for all of you to see. So take a look at this memory address. Now, what this means essentially is that I have a root drive called D. And within that root drive called D, there's a folder within that root drive utilizing the / to indicate that there's a folder called documents within my drive D. And within documents, there's another folder called Zoom within my directory called documents, utilizing the /. So the / in this case is meaning that there's something within another thing. There's a folder within a folder within a folder, and within that folder, there's a file. Yeah. That is what a full stop or a period signifies in Python. This item, of which I'm calling back from the right, is within the object within the left. Okay. So you can utilize this same concept here in Python utilizing data frames, whereas you can just call df.marks and we get the same result as we did up here. Here, as well as running another operation such as getting .marks, and we get the same result. So that's something that you might keep in mind. Okay, so what if we wanted to see a statistical breakdown of our data set? There's this function called .describe. Now, what .describe does is it allows the machine to go through your data frame, specifying only on the numerical data type columns, and it's all able to give you a statistical breakdown of that particular column or each particular numerical column within your data frame. In this case, we only had a single column that had numerical values, which was marks. So when you call .describe, it will ignore the non-numerical columns and focus on this particular column, whereas it's going to give you the count of the values, the mean of all the values within that particular column, the standard deviation, the mean value, first quartile, median, or second quartile, third quartile, and then the maximum value within that particular column. And this is very crucial, especially when you're trying to identify outliers. Though we're going to see another way, which is more convenient when you're trying to identify outliers within your data in a visual sense, called using a box plot. However, this is the very background of how that process works. We can also call .info. Now, dataframe.info or df.info in this case gives you a well-structured and a well-defined information bar of exactly what is going on within your particular data frame. From the index range to the column names to how many non-values exist within each particular column, as well as each data type within that particular column, as well as giving you a breakdown of how many data types are within your particular data frame and the memory size of which your particular data frame is holding currently. So it's a wealth of information, especially when you're working with large data sets, as we'll see down below.